As a consequence of unstoppable technological development and our quality of life, the demand for electricity has grown exponentially in recent years. If we add to this situation the need to draw on energy sources that are sustainable and environment-friendly, we can assert that it is of the utmost importance that we encourage a profound revolution in the management of electrical power. To achieve this, in October 2005, the FENIX project was set in motion under the auspices of the European Commission and launched with a budget of close to 15 million euros within the 6th Framework Programme Sustainable Energy Systems. A consortium of 20 partners from 8 different European Union member states form part of this initiative, including transmission and distribution system operators, manufacturers, business consultants, universities, and research centers. The objective of the FENIX project is to increase the penetration of distributed energy resources and its integration in the grid in a way that strengthens their contribution to the power system. This will improve sustainability of the network and the quality of service, will reduce CO2 emissions, and will lead to new business opportunities. In order to launch this project, revolutionary software was developed and is now being tested on a smaller scale before it can be put into use throughout Europe. The scenarios chosen for these field tests are Woking in the UK, hosted by EDF Energy, and Álava in Spain, hosted by Iberdrola Distribución Eléctrica, which were selected because they are representative of European networks and scalable to national levels. The expected results could be extrapolated to all of European society. Iberdrola, Spain's largest power company, has more than 10 million customers and operates in 14 autonomous regions, which represents about 40% of the electricity distribution business in Spain, is one of the partners of the FENIX consortium, and explains why Álava was chosen as a test area for the FENIX project. The presence of a big amount of already distributed installed generation capacity and a European average network, 2,000 kilometers of power lines with 70% of urban and semi-urban areas, attracted the attention of the consortium. In addition, Álava presents a clean cut between transmission and distribution networks. Anything done by FENIX at the distribution level will be clearly seen in 8 boundary transformers. A variety of players are involved in carrying out this test. Several energy producers using different technologies and sizes. CHP or combined heat and power, hydroelectric, solar, wind, and biomass. System operators. Red Eléctrica de España is responsible for the transmission network and Iberdrola Distribución for the distribution network. And the market operator OMEL, Compañía Operadora del Mercado Español de Electricidad, who basically organizes and regulates the supply and demand of electrical power in the day ahead. In addition, the FENIX project includes a new actor who will play a leading role from now on, the aggregator, whose mission will be to coordinate the various energy producers and to act as the intermediary between them, the market, and the system operators, in order to guarantee the proper supply of energy in both normal and exceptional situations that will be grouped in 4 possible scenarios. The aggregator legally represents a portfolio of generators and knows their situation in real time thanks to a piece of equipment called a FENIX box, which allows bidirectional communication between the DER and the aggregator. The aggregator knows in real time the status of each DER, but he also sends set points and commands to them. This new actor requires new tools such as DEMs that help him to perform all these functions. This opens a new set of business opportunities such as consultancy and advice to his associates. In the day-ahead market, or the normal scenario in the power supply, the aggregator acts as an intermediary between all the parties involved within a perfectly coordinated system. Every day, The electricity generators contact their aggregator via internet to inform him of their predicted energy production for the next 24 hours. All the aggregators, in competition with conventional generation, inform OMEL and Iberdrola of their forecasts. The OMEL compares the supply and the demand and tells each aggregator the amount of energy the producers have been assigned to generate and at what price. At the same time, Iberdrola tells the aggregators whether the amount of electricity that their producers are going to generate the following day is technically feasible and ensures that it will not cause problems in its network. The distribution system operator provides the aggregator validated program where the energy is sent and what offers are rejected. Likewise, the aggregator tells the transmission system operator, Red Eléctrica de España, how much electricity it is going to provide and through which node, so it can check whether the transmission network is technically able to handle that amount without problems. The transmission system operator, Red Eléctrica de España, uses the program created by OMEL to check if there is any problem in the transmission network. Iberdrola tells the aggregators whether the amount of electricity that their producers are going to generate the following day is technically feasible and ensures that it will not cause problems in its network. Once he has received this information from the OMEL and Iberdrola, the aggregator decides which producers meet necessary conditions to generate the power needed and at what price per kilowatt, optimizing his portfolio. Urquilla Wind Farm, 17 megawatts. Antoniana Mini Hydraulic Plant, 0.44 megawatts. Huascor Biomass Enviroil, 2 megawatts. Michelin, 35 megawatts. Let's imagine that it's 8 o'clock in the morning and the producers are sending the energy that the aggregator asked them to deliver in accordance with his forecast. Everything is going fine until at 10 a.m. the wind starts blowing harder than the weather forecast predicted. So the aggregator evaluates the situation and decides what producers he can ask to reduce their production to compensate for the extra wind energy in order to meet his commitments. With the Phoenix project, no matter what the situation, it is possible to react immediately and adapt to new conditions. Tertiary reserve. One of the responsibilities of Red Eléctrica, as transmission system operator, is to predict the demand and determine a buffer margin that will guarantee the power supply should the real demand end up being greater or lesser than what was forecasted. This margin is made up of different power reserves with different answering response times. One of them is called the tertiary reserve. When Red Eléctrica observes that the deviations that are occurring are reducing the tertiary reserve and may create a hazardous situation, it asks electricity producers, including the aggregators, to increase or reduce their electricity production. The day ahead, the aggregator informs Red Eléctrica of the capacity of his producers to modify the power they produce, up or down, in 15 minutes. When the system needs tertiary reserve to recover the secondary reserve that is in use, Red Eléctrica uses the offers that were sent the day before. This reserve is of great value to avoid undesired consequences to the system, like load shedding. Voltage control. The voltage at the transmission grid nodes must be kept within certain margins at all times. This is controlled by Red Eléctrica, the transmission system operator, which requires Iberdrola, the distribution system operator, to maintain the flow of electricity necessary within those margins. The development of the Phoenix project provides Iberdrola with new tools to optimize the available resources, including distributed generators. We're convinced that the Phoenix project is a good tool that will make it possible to integrate distributed generation on a large scale. We believe that this tool will facilitate its greater participation in the complementary services and therefore its improved support of the electrical system.
Before, we had to work hard to maintain the supply of electricity within the parameters that Red Eléctrica required of us.
Sometimes we've even been penalized when we weren't able to achieve that. Now with the Phoenix project, we've got complete control. Thanks to the Phoenix project and the aggregators, the voltage can also be controlled in real time and with the highest level of coordination among all the actors involved. The way it works is simple. Red Eléctrica communicates directly with producers through the Secre Center. It also communicates its decisions to the distributor, Iberdrola, about the flow levels that it should maintain so as not to surpass the established margins. Iberdrola communicates this information to the aggregator, who in turn selects the best producers to provide this service with all the guarantees. Contingencies. In rare circumstances, difficult and serious situations may arise that jeopardize the power supply and that must be resolved quickly to restore service as soon as possible. Let's imagine that a bird flies into the transformer at a power plant and causes a 1,000 megawatt shortfall. Then Red Eléctrica, which is ultimately responsible for the health of the national system, uses the tertiary reserve offers that were presented the day ahead to recover the secondary reserve that was instantaneously used to cover the 1,000 megawatt loss. The need of using the tertiary reserve implies that the aggregator has to provide energy as soon as possible. The aggregator reviews the forecasts and decides which producers will have to step in and inject more electricity to cover the shortfall and solve the problem in less than 15 minutes.
It's a good feeling to know that our work contributes to improving the country's electricity supply. This job, which we sometimes carry out under great pressure, is worthwhile because it directly affects the welfare of society.
In short, the Phoenix project is a real and efficient solution to ensure control over the supply of electricity. It can organize a myriad of producers that are joining the system spread all over the distribution network, help to control energy flows and the voltage levels, and reduce the impact of any contingency. And he does all this with one objective in mind: the welfare of society in general and the satisfaction of each individual consumer. That is why we can say that the Phoenix project is a true network of opportunities to enjoy a better and more sustainable future in Europe.